Welcome to the Learning Pines YouTube. We hope this video helps.
You start by converting the complex number to polar because de Moivre works on r and theta. First, compute r equals sqrt, a 2 plus b2. This gives magnitude. Then find theta using aton 2, b, a, and make sure the angle lies in the right quadrant so sin and cos signs match. Once done, write z equals r, cos theta plus I sin theta, or r e a theta. This sets up a clean, actionable form for raising to powers or extracting roots without messy algebra. You now apply de Moivre directly. For an integer power n, raise the magnitude to Rn and multiply the angle by n, giving Rn, cos n theta plus I sin n theta. For nth roots, compute R1/n and the set of angles theta k equals theta plus 2 pike slash n for k equals 0 to n minus 1, which yields n distinct roots. Make sure to reduce angles modulo 2 pi so values sit in the principal interval. This avoids duplicate representations and clarify. You finish by converting polar answers back to rectangular form. Compute real part r cos theta and imaginary part r sin theta for each solution. Once converted, verify by substituting the result into the original equation or by raising roots to the given power to confirm you recover the original complex number. If something goes wrong, re-evaluate the argument quadrant and ensure angles were correctly reduced modulo 2 pi. This common fix resolves sign errors and duplicate roots.
Thanks for watching. Consider subscribing if we helped you.